Alright, so just like with those other bits of information about quadratics, you can also get a lot of information about the maximum and minimum values from a graph, but you can also get it from the equation itself. So whatever a is, the term out front, if it's positive, then it has a minimum value. If it's negative, it has a maximum value. And wherever those vertices are, will tell you where those points are. So, yeah. So we're going to take this and determine some information about this equation just based off of what we're given. So we want to first determine whether the function has a maximum or minimum. So since there's a negative out front, so it has a maximum value. So the graph looks like this at some point. So part B, state the maximum or minimum value. We know, again, it is a maximum value, so we can ignore that part of the function. And again here, so if you remember what you just did, to find the x-coordinate for the vertex, or the x-coordinate for the, or x-equation for the axis of symmetry, you use this equation, x equals the opposite of b over 2a, right? So that can get us our x value, then we can plug that in and find our y value. And that'll give us our vertex then. So we have a b of 2, was negative 2, over 2, and our a is negative 1. So that's negative 2 over negative 2, or positive 1. So we plug that back in. We want to know what f of 1 is. That's a negative 1 times, or 1 squared, sorry, plus 2 times 1, plus 3. So that's going to be negative 1. So because 1 squared is 1, but the negative is outside of the parentheses, so it's a negative. Plus 2, plus 3, and that's going to be 4. So our maximum value is 4. Our vertex is at 1, 4. It doesn't ask us for that, but it's good information to have. And then we want to state the domain and range. So again, I have a few options on how to do that. The domain here for really any parabola is always going to be all real numbers. Or if you like the parentheses version, it's negative infinity to infinity. For the range, these are just kind of dependent on that maximum or minimum value. This one has a maximum, so it's going to go from negative infinity. Actually, we're just going to say it's all y's less than or equal to 4. Again, if you like the parentheses version, then it's negative infinity to that 4, and it includes it. And that is it. So this next one is a more real-world based problem. We need to come up with our equation ourselves. So we're going to have to multiply some binomials, and we haven't really looked at that yet. So what that means is we're going to use something called FOIL, which is first, outer, inner, and last. So we're going to use that here in a minute, and you'll see what that means. So here we have the souvenir shop sells about 200 coffee mugs. It's for $6 each. The shop owner estimates that for each 50 cents increase in price, he'll sell about 10 fewer mugs per month. How much should he charge per month for each mug? Or sorry, how much should he charge for each mug in order to maximize his monthly income? So we have two things here, right? We know that he has M, which is the number of mugs, which he knows that he typically sells 200 a month, and that if he decreases or increases the price, he's going to lose 10 for every 50 cents he drops or raises the price. And then for the price per mug, that's going to be $6 to start, and he's looking at adding 50 cents each time. And again, x is the number of increases. So we know that when we multiply these two equations, we get our income of the number of mugs times the price per mug, right? Tells you how much he's going to make. So that means we're going to multiply these two binomials together. 200 minus 10x and 6 plus 0.5x. And when we multiply that, we need to use FOIL. So we're going to multiply the first two numbers together, the outer two numbers together, the inner two numbers together, and the last two numbers together. That's why it's called FOIL. So for those first two numbers, 200 times 6 is 1200. And then 200 times 0.5x is going to be 100x. Negative 10x times 6 is going to be negative, right? Because a negative times a positive, and 10 times 6 is 60x. And then again, negative times a positive is negative. 10 times 0.5 is 5. And that's x squared. And then we have some common terms together, we can combine together in the middle here. So that's going to be 1200 plus 40x minus 5x squared. Now, we are looking for his maximum, right? So that means we are looking for, big shocker here, is maximum value. So we just need to find where that is for x, plug that in for the price part, because we don't really care about how much money he's making. We want to know how much he needs to charge to make his maximum profit. So first we need to find our x value. Remember, it's opposite of b over 2a. Our b value is 40, so it's negative 40 over 2, and our a is 5, negative 5. So that's negative 40 over negative 10, which is just 4. So now we know our x value for our maximum is 4, so we're going to plug that in for the profit part, the p. So p, again, was 6 plus 0.5 times x, in this case 4. So 6 plus 0.5 times 4 is 2. So he should charge $8 per mug to maximize his profit. There's a second part to this. So let's take a look at that. So this one wants us to find his maximum monthly income. So now we want to actually figure out the rest of this, right? Figure out what that maximum value is for the y side. And again, here's our equation. That's our I, which is income, right? So we want to find our maximum for that. We know that the x value is 4. So all we have to do is just plug in the 4 to this, and it will give us the y value that is the maximum. Or the I value that is the maximum. So 1200 plus 40 times 4 minus 5 times 4 squared. Forty times 4 is 160. And 4 squared is 16. 5 times 16 is 80. We're going to go ahead and add the 1200 and 160. That's 1360. So 1360 minus 80 leaves us with his income per month just based on mugs. Hopefully he sells more than just mugs, because he's only making $1,280 on the mugs. It's not terrible for selling just mugs, though. This next one, we want to again solve this, or now we're going to solve this by graphing. So what that means is we're looking for where it crosses the x-axis. So let's plug in some numbers. So we're going to do -5, -4. Just going to look at the graph. We kind of want to lean towards the negative side. Let's just do negative numbers. So when we plug those in, -5 squared is 25. -5 times 6 is -30. So that's going to leave us with -5. And -5 plus 8 is 3. -4 squared is 16. 6 times -4 is -24. The 16 and -24 is going to leave us with -8. -8 plus 8 is 0. -3 squared is 9. 6 times -3 is -18. -18 plus 9 is -9. And -9 plus 8 is -1. -2 squared is 4. 6 times -2 is -12. -12 plus 4, is going to be -8. And -8 plus 8 is 0. So right now we already got our solutions just by the table, but that's okay. We're going to keep going. And this one just gets that's 3 as well. So our solutions without the table, or without the graph, are at x equal to -4 and x equal to -2. But graphing these, -3, we're at -1, here and here. Here and here. So all we're looking for is where it crosses the x-axis. That's what it means by solving the equation. And that's it. There's our two solutions. So this is what you would get for every time you either have one solution where it crosses the x-axis one time, basically the vertex is on the x-axis, or you have two real solutions where it crosses like we just had, or you have no real solution where it doesn't cross at all. And we'll talk more about what happens whenever we have no real solution later on. But for now, we're just focusing on when we have real solutions. Because, there's an opposite thing to real.